Hello, everybody. Welcome to this event. It's lovely to see you people here in person, and welcome to everyone who's online as well. Thanks for that introduction, Ursula. It's my pleasure to introduce my colleague, Professor Ken Catchpole, here today. I first met Ken, we were talking last night actually about when. It was way back in the kind of, 2008, 2009 time when he was working at Oxford and I was working in London. And I remember just visiting his office. I was involved as an advisor on one of the surgical safety projects there. And I remember, chatting with Ken and going into his office, and he had this little corner full of books and papers and so on. And he was one of the very first people who'd actually managed to go into operating theatres and observe what was actually happening and apply human factors thinking. So it was all very exciting to actually go and actually see that in practice at Oxford. So it's wonderful to have him here today and for him to share his expertise. He told me he doesn't want much of an introduction because it's embarrassing, but I'll give you a little bit of an introduction anyway. He has over 22 years of international research across many different surgical specialties and healthcare systems. And of course, now he's based in the US instead of the UK. He's worked in many different areas of perioperative safety, such as sterile processing, retained foreign objects, specimen handling, diagnosis, neonatal resus, speech interference in surgery, and so on. And I'm sure he's going to tell us about some of those today. He has about 165 publications, over 150 invited lectures. So I'm sure he has lots of expertise to share with us today. So please welcome Ken to the podium.
Thank you so much. And so it's wonderful to see that that there's a growth in the interest and a growth in the value of what this expertise can bring. I've had this amazing opportunity to work closely alongside clinicians, particularly those in surgery, but also in acute care, doing amazing things and being able to bring the kind of perspective that human factors brings to that has been a really wonderful opportunity for me. And so I get to talk about that. So thank you for being here, and thank you for at least being prepared to listen to me for a little, for at least 5 or 10 minutes anyway. So human factors is about the understanding of interactions among humans and other parts of the system in order to optimize well-being as well as system performance. So this is the idea that we as humans exist within a context. And so anything that, when we talk about the system is kind of the human plus that context, whatever that context is. And in this, in the way we think about it, we can think about it as an operating theatre. Sometimes I'm going to say operating room because I'm so culturally confused by now. So this is the idea that we exist in a context, and the context influences our behaviour, and that therefore, if we think about the mix of the humans and the context, the tasks that they do and the technology that they use and the workspace that they're working in, the reasons why they're doing it, the organization that sets the kind of tone for all of that and provides, then it gives us an opportunity to think about how all of those things can affect the performance, the outcome of our patients. It comes from, how are we doing? Yes, it comes from in recognition in the mid-40s, early to mid-40s, with the design of these very complex aircraft, including this one, the B-17, where we recognized that design could play an important role in creating the opportunities for accidents. So rather than blaming pilots for accidents like this, psychologists started to investigate what was going wrong. And in this case, the B-17, they found that these two key switches, one for the landing gear and one for the flaps, were very close to each other and easily confused by the pilot who's looking out of the windscreen, focusing on landing, and is reaching down for one of these two switches. The flaps help you fly slower without falling out of the sky. The gear is obviously what you need to land, but will slow you down. So if you drop the gear thinking it's the flaps, then you're likely to lose height very rapidly, which can lead to an accident. So rather than blaming somebody or giving them a checklist or saying that they should try harder, that actually it became a design issue. And so nowadays, when you go onto an aircraft, the gear lever is circular. It feels in your hand like a wheel. So it tells you just by touch, this is the wheels, and the flaps is like a flap. It feels in your hand like a flap. The point here being that once you can bake into the designs ways in which you can prevent errors from happening that can lead to catastrophe. And so healthcare has been kind of slow to start thinking in this way. So when we talk about context, that's a great example of context. If you change the designs, these accidents are less likely to happen. Indeed, one of the interesting things for me, having looked at doing lots of observational work in surgery, is that this idea actually isn't new. And even before that, in the 20s and 30s, this guy, Frank Gilbreth, who's one of the sort of pioneers of what they call scientific management, time and motion studies, studied operating theatres and looking at what surgeons were doing, and found that surgeons were spending more time looking for their instruments than they were operating on the patient. And so, which is where we get scrub nurses. Scrub nurses being there to facilitate that, so the surgeon can spend their time on the surgery and not time looking for instruments. So it's sort of really interesting that some of this is so baked into what we do that we've forgotten that that's where it comes from. And so when it's sort of a privilege. So, and somewhere along the line, we stopped doing that kind of work in surgery. But that gives you an idea of how, once you think about this, how profound this change can be to the benefit of everyone, and also sometimes how invisible some of this stuff really is. So I started at Great Ormond Street Hospital in London, looking at congenital heart surgery, about which I'm still fascinated. It's amazing. And we had the privilege of putting video cameras in. This is 20 years ago. You can see this sort of thing is available in a tiny little camera now, and all those sorts of things. But starting to look at the processes and teamwork and all the things that go into successful congenital heart surgery. And I became sort of fascinated with particularly the relationship, the relationship with perfusion, and how perfusion and the perfusionist, and the relationship between the surgeon, the anaesthetist, and the perfusionist has profound effects on how they relate and how they communicate, has profound effects on how smooth that operation can go. Here's a transcript of an event that happened that we observed around modified ultrafiltration, which is essentially where, towards the end of the operation, you have, it's been a while since I remember this, but you have the perfusion cannulae, and you essentially reverse the flow of the pump. So you taking out of blood from the aortic, the aortic cannula, and put it and filtering the blood, purifying it, and putting it back into the atrial appendage. So what this does is it improves the outcomes for patients. There's this figure called hematocrit, which is really, and somebody, this is how limited my understanding of it is, but it's about how concentrated the blood is, how much kind of stuff is in the blood. So once you do this modified filtration, you have a target hematocrit. You filter to that hematocrit, you stop filtering, and that gives you a good outcome for the baby. Well, in this case, the perfusionist says, right, filtration stopped. We've reached the target hematocrit. The anaesthetist says, what's the hematocrit? Perfusionist says 40. The consultant anaesthetist to the perfusionist says, I think we can do a little bit better than that, with the idea that actually the more we can filter, then the better this is going to be better for this baby. So, but the surgeon has heard filtration stopped and has taken the line out of the atrial appendage, which means that blood is coming out of the baby and not going back in anymore. And the first assistant surgeon is sort of involved in the planning, but thinks something else is going on, so doesn't realise that what's happening. And so then this team go on looking at blood gas, looking at acidosis, that sort of thing. And then eventually the surgeon says, oh, by the way, I took the muff line out. The perfusionist says, well, I'm glad you said something because we're still filtering. How much did we take out? Right, we stopped. We stopped that thing from happening. But for 2 minutes, we had blood coming out of the baby and not going back in. So this is telling us something about risks. And I forget how frequent or infrequent mechanical exsanguination on the table is, but it happens. So this is already seeing, and just in an everyday example of how the themes of how these things can go wrong are there all the time. And that mostly it's people communicating and anticipating and covering for each other and understanding what each other needs to know that stop these things, going from bad to worse. So what I became very interested in is teamwork. And this is and we were also doing studies with orthopedic surgery and how different teams in orthopedic surgery communicated in comparison to the teams in cardiac surgery, and what the teams do and how they communicate and the technology that they use and the processes that they use were all interrelated. So in orthopedic surgery, you don't need a whole lot of communication. The anaesthetist is often separate. There are specific times when they're applying the bone cement that it helps for the anaesthetist to know, because patients can respond to the bone cement badly. But actually the key relationship is between the scrub nurse and the surgeon, and particularly having a scrub nurse who knows how to use all the jigs and all the things that you need for a knee replacement or a hip replacement, which is very defined by all the things you need to use, whether it's kind of Zimmer or all the other manufacturers that I've forgotten. Whereas in cardiac surgery, the key relationship, as I said, is between the surgeon, the anaesthetist, and the perfusionist. And the surgeon and the anaesthetist are consultants, they're physicians, and they don't like to challenge each other. The perfusionist is a technician. And so the first thing I noticed, one of the early things I noticed, was that the surgeon would say something to the perfusionist, the anaesthetist would say something to the perfusionist. I would say, hold on, you seem to be getting two different commands from these two different people. And the perfusionist said, yeah, and I do the third thing, which is right. The other thing about this relationship is that you have two physicians who don't like to challenge each other and a perfusionist who's a technician. When anything goes wrong, who do you think gets the blame? There you go. So already we have a loaded situation that if we understand this relationship, then maybe it can tell us something about how we can make sure that this relationship doesn't go wrong. That actually anyway, so you get the idea here. Anyway, so that's why I'm fascinated by cardiac surgery and the role of perfusion and how that works. Anyway, another classic one is the patient goes on pump, the anaesthetist goes vasodilators and goes off for a cup of tea, because they can do that, and then the perfusionist has to raise the perfusion pressure, which means that then the surgical site fills up and the surgeon's stamping their feet saying, why are you not draining properly? And the perfusionist is saying, well, it's because the anaesthetist has done this. So anyway, those sorts of things are probably observable. And at this point, I have to confess my lack of really detailed understanding, but I think you get the point. Anyway, so this is another event we observed, which is actually one of the reasons why I was sort of here in this case. This registrar was opening, it was a reduced stenotomy. I think it was a Norwood stage 2, certain type of, and so this is a kind of 3-stage surgery for, I think, hyperplastic left heart. Anyway, so this is a sternotomy, and reduced sternotomies tend to be more difficult because there's lots of sort of adherences. And in this case, there was an existing homograph from the previous operation that was, I think, probably stuck to the back of the sternum. So when the registrar opened, it opened a hole in the homograft in the aorta. And according to the data, there's a 5% chance of this happening. So is this an error or is this not? I would say it's probably not an error. I think this is probably just one of the things that might happen. Anyway, the registrar puts their finger on the hole and says, please go, neither the consultant surgeon nor the consultant ânesthetist were in the room because this was opening, and sticks the finger on the hole and says, please go and get some help. 2 minutes later, fairly quickly, both surgeon and anaesthetist arrive. The blood's increased. The surgeon says, give some heparin, please. And what this means is, give some heparin, we want to go on bypass. We need to get on bypass very quickly. The surgeon says, don't do that, and goes off to scrub up. And the registrar, who knows what's going on, says to the consultant anaesthetist again, please give some heparin. Heparin protocols, which I'm another fascination of mine, I don't get to talk about today. But to do that, the anaesthetist says, okay, heparin going in. And the surgeon who scrubs up comes out and says, I said no heparin, and sees what's going on and realizes that this is the right decision. So this is a very, very brave thing for the registrar to do, which absolutely saved this baby and overruled his boss. I've never seen anything like this. This guy, by the way, was an awesome surgeon, and I hope he's still operating. So anyway, and then after that, there was a kind of huge struggle with all this equipment to get this patient crashed onto bypass because it was a very, very serious thing. But eventually, everything worked out okay, and there wasn't any negative effects of this event. But again, this whole event was 3 words. 3 words in the patient's notes. So the only record of this is the one that I took in being there and observing this. Okay, so a principle we have in human factors. How am I doing for time, by the way? I totally forgot to. Thank you. I totally forgot to start my timer. So there's a principle here called work as imagined versus work as done. Work as imagined being what you might think happens in an operating room or operating theatre if you've never been in an operating theatre. Work as done is being this messy business that some of which I've been talking about, of what it really is like to work in an operating theatre. And when I first started this, one of the registrars would say to me, hey, what you're doing is really interesting, of going into operating rooms and talking and doing studies of what's going on, because there is an unwritten rule. What goes on in the OR, in the theatre, stays in theatre. I thought that's a really interesting idea. How do people ever learn? And so to a certain extent, those of us who have spent, people who haven't spent time are always thinking about work as imagined. So this is what a device manufacturer might think an operating theatre looks like. It doesn't look like any operating theatre I've ever been in, nor what might ever be in. This is more like it because it's cluttered, it's got real equipment in. This is more like it because this has got lots of people in and lots of things going on. And then these are photos that I've taken from operating theatres in the US and the UK, in average hospitals and in hospitals that like to think they're the best in the world. And so hopefully what this illustrates is all the messy business that this involves, that this isn't not a nice, neat thing to do, that our systems are the best they can be, but they rely on people to hold them together because there's lots of messiness that goes on. So this is the difference between work as imagined, thinking that, oh, our systems work if it wasn't for the people, and work as done, which is we rely on people to hold these messy systems together and to do the right thing to make safety and to enable us to perform in the first place. So work as imagined versus work as done. We have protocols that don't account for all eventualities. Saying they should have done something doesn't explain why they did it. Another word for cutting corners is innovation. What we do is evidence-based. Well, there isn't evidence for everything that we do. It's rare, it's debated, it's not behaviorally motivating. People don't change their behavior based on evidence. And it's socially constructed. What this group of people think is evidence might not be what this group of people have evidence. The example I use is that in the UK you can't have anything below the elbow and can't have ties as a way to prevent infection within hospitals, whereas in the US, all the doctors wear their white coats and ties. There's probably evidence, you could probably ask each of those groups to produce evidence that their way of doing things was the right one. I don't know. That's not to say that, and then training, we know that there's a gap between training and practice. It's not how I don't care what you've trained them in, that's not how we do it here. And it's policy, unknowable. There are too many policies to possibly even know. It's unknown, I didn't know there was a policy for that. It's unavailable, I know there's a policy, but I can't get to it when I need it. Or it's unrealistic, it's a 30-page policy for a 5-minute job. That's not to say all of these things aren't valuable, it's just that they are not what our work is fundamentally based on. They provide maybe structures to help us, but they're not what, and so strict adherence to policy is not how healthcare is delivered, or protocols, or evidence. They all help, but they're not. And so we rely, so this is the difference between work than work is done. So work as imagined is clinical systems are linear and deterministic. Well, no, they're not. They're complex and adaptive. When it comes to the relationship between error and harm, this is important because this says that a bad outcome must mean that there's an error and that a good outcome must mean that there weren't any errors. Rubbish. This means that there are tons of errors all the time. You can stand in an operating room and operating theatre and count an error about every 6 minutes. But the point is that our systems are robust, which means that those errors don't lead to harm in all sorts of ways, including some of the ways that I've talked about. And these are some of the grosser examples, obviously. So the idea that a bad outcome meant that our process must have been bad, or that a good outcome meant our process must have been good, is nonsense. You can have a terrible course for a patient and still have a good outcome, as I've demonstrated, or you can have the best care that you can possibly give a patient and you still have a bad outcome, because guess what? Healthcare has a 100% fatality rate. So this is one of the biggest payouts in UK medical legal history. It happened with a girl who was having neurosurgery and got brain damage because there was a mix-up between a sort of glue syringe and one of saline. Accident happened when 2 syringes got mixed up in the operating theatre. One of the top 10 biggest payouts in UK medical legal history. The sort of thing that happens when, natural reactions to failure is, who did it? There was a sequence of errors. Why, how did this happen? Why didn't they do these other things that they could have done that would have avoided this? And that what they should have done is this. All of these are not very helpful because they're a reflection of hindsight bias. If the syringes, so this is kind of from the legal narrative around this case, if the syringes had been marked up so that the hospital could see which contained glue and which contained dye, then Maisha would not have suffered what is an utterly devastating brain injury. Such easily avoidable mistakes should not happen. That's the sort of thing that you read within, with these sort of narratives. Nice, it's all hindsight bias, however, because I was in that unit 18 months before with that team doing some observations, and this was a VP shunt a tube from the brain to the stomach to relieve pressure in the brain. There were 4 people at the operating table instead of 2. There was a new scrub nurse and there was 2 surgeons. So you know, with a sort of more junior surgeon with a kind of a senior colleague. And during the early stages of the operation, lots of the things don't work. In fact, in my observations, almost every single surgery, some piece of equipment doesn't work right. Anyway, in this case, there were a bunch of pieces that, you know, in fact, what they had was a drill that was a pneumatic drill, and somebody had clamped the pneumatic line to the table, which had occluded the line. Nobody realized this. Anyway, so this was kind of creating this whole turbulence. And you can see this all the time in operating rooms, you know, not every surgery, but you see, you know, you can see these things not working and people trying to solve these problems. Eventually they solve the problem. This team were also working in a different part of the hospital, which meant that they didn't necessarily have the best equipment that they would have chosen. They were having to work with equipment that, you know, that wasn't optimal for what they wanted. But in this, you know, you've got kind of all this stuff going on. And then during the surgery, this new scrub nurse is trying to deal with requests from the 2 surgeons, and in trying to do this, mixed up a syringe of saline with a syringe of chirocane. Now, I understand, and you might be able to tell me more about this, that chirocane is not something you want to get in contact with the central nervous system. I don't know, but in this case, these 2 syringes got swapped. So I was in this 18 months before, you know, in this unit 18 months before, looking at a syringe swap that then led to this dreadful outcome later. This wasn't, and then in this case, the experienced scrub nurse realized what was happening and said, "No, stop, don't do that," and totally recovered the situation. So the point here is that maybe our systems don't work as perfectly, and looking backwards can give us a false impression about the work, the everyday work that's done, which is a lot of people holding the system together. So when something goes wrong, it's a failure to hold that system together, which is already vulnerable and already risky and already imperfect. And so blaming people and saying what they should have done post hoc doesn't necessarily tell us a whole lot about how to fix it. So this was definitely not just a labeling problem. A more useful way to think is, how did this seem reasonable at the time? Why is it that somebody would make these decisions that led to this outcome of this patient, knowing that nobody comes to work to harm patients? So looking backwards and saying what they should have done isn't as helpful as saying, why is it that it made sense for them to make these decisions that led to this bad outcome? And particularly because the world is messy and we as humans are having to navigate all of these threats all the time, any one of which might have a significant impact for us and our patients. And so this is what we call reconstruction of the mindset, or walking in somebody else's shoes rather than ostracizing them for making a mistake. Okay, so this is the sort of narrative. 237 million medication errors every year. Well, I mean, I'm sorry, it's rubbish. It's a great headline, but error and harm are 2 very different things. One of the biggest problems within patient safety is mixing up error and harm and calling harm errors. Harm is harm, errors are something different. This is the, sorry, some of the formatting's gone wrong here, but this is the idea that there's a chain of events. Actually, there's never a chain of events. It only looks like a chain of events afterwards. This is the complexity, and this is a particular clinical event. How am I doing for time? Anyway, okay, thank you. So when you start looking at the complexity of these events, That's what's really happening is not a chain, but there's a kind of matrix of lots and lots and lots of things going on, and lots of threats that are being addressed all the time, but maybe one of those wasn't addressed. So in fact, I'm doing some really interesting stuff with how teams dealing with these problems that can escalate. So the idea here is that problems escalate into harm because you have teams dealing with these challenges, these imperfect, systems that start a snowball effect. So one thing leads to another thing, leads to another thing. That's what leads to harm. It's not that somebody did something wrong. So there's a lot of, this is some stuff on what we might call a cognitive error, and I've come across this in anesthesia. I came across, we were doing some work with anesthesia and medication delivery, and came across multiple instances of over, I think it was over prescription of paralytic. Not because we had multiple instances of anesthetists who couldn't do their job, but because the display that they were using, which I think they have what's called the train of five, is that right? Which is which sort of measures the level of I think paralysis of the patient. Again, I'm not entirely sure, but the point here is that the design of the machine displayed it in a way that misled the anaesthetist to think that the patient needed more drug that they did not. And this happened multiple times. There is no evidence of this because nobody knows to report it. People report it as a cognitive error. These are all the different things, the devices that an anaesthetist might use in surgery, or some of them, and all the different ways in which those devices can mislead somebody about the work that they're doing. And the real expertise of an anaesthetist is knowing all of these things and being able to navigate around them. Because the first thing that happens one of the first things that happens when there's an unexpected or deviating reading on any one of these devices is quite rightly the first thing to do is check whether the device is working, because often it's the device that's misleading that's causing the display, that's having a display problem. But the point is that we don't report that, we only report the cognitive error. We don't report the fact that maybe it was the device that was entirely designed in the wrong way or was unreliable. And we don't really recognize that one aspect of expertise is within clinicians is understanding that their machines don't always, that their displays can be misleading, and that so a healthy mistrust of the work that they're doing of the displays that they're using is actually a very, very reasonable thing, and it's part of a sophisticated understanding of clinical work. This is all the different outcomes that an anaesthetist might have to balance, or some of the different outcomes that an anaesthetist might have to balance when they're thinking about the delivery of a certain drug. What the patient wants, what the family wants, by the way, the surgeon might want, what their colleagues might expect to see, what their regulators or their professional standards might want, and what their organization might want in terms of don't use those drugs because we haven't got many of them, or they're expensive, so use these. And so any decision about a medication is not only about the evidence, but also what's right for me and my team and this patient in this organization with this surgeon in this context on this day. This is what expertise is. And so one of the wonderful things I think about human factors is that it starts to reveal actually a lot of the real expertise that goes into clinical work in a way that I don't know is always talked about. So in fact, rather than there being this wonderful system that would only work if people did what they should do, and that the errors are, what creates the problems, No, we actually have people who are navigating all the time these variations and these challenges and these imperfections in the system, and using their expertise to balance all these competing outcomes and all these competing pressures to come to the best conclusion, to deliver the best care they can for that patient at that time in that context with those resources. Not blind adherence to a policy that was never going to work in the first place. So humans are a unique and fundamental component of any system. There's often talk about we should design out the human because they're weak. No, they create safety in complex systems, and complex systems are inherently unsafe. It is not safe to take a knife to skin. It's not safe to give somebody a dangerous drug. What we're doing is trading short-term higher risk for long-term benefits. If you want a safe hospital, lock the doors and don't ever let anyone in. But so it becomes about risk and the management of risk. Complex systems always risk and hazard. Complex systems always function at the limits of their capacity. We're always trying to do more for less. And they require safety to be traded for other aspects of system performance. We can't have, it doesn't matter, if we've got a wonderfully safe hospital, but one that's financially, unfeasible, it's not going to work. So we need to recognize that there is a trade-off between how much we do, the cost we do it for, and the thoroughness or the safety with which we're able to conduct the work. And indeed, we can't change the humans, we can change the context in which they work. So we've got the idea here is that there's a brain and that interacts with the world in these different ways using controls and displays, and that's within a working environment or an environment, and that's within an organization. So instead of saying who did what wrong, you can say who was doing it, what were they doing, what were they doing it with, where were they doing it, and why were they doing it? And immediately that gives you a new bunch of ways to think about what might create certain types of behaviors. Okay, 5 minutes. All right, I need to probably speed up. This is an example of design. It's an intraosseous bone injection device. I came across this one because, to cut a long story short, you can reverse it in your hand and inject the spring-loaded needle into the back of your hand. How do I know that? Because I came across a registrar who'd done that and said to me, it was my fault, I should have looked. And I said, no, this is a design decision. If you have an IO device that has a pistol grip, you're not going to make that mistake. You can design that out. These are dangerous designs. This is my favorite human factors slide because I often think that this is what we do to our clinicians. And I met an anesthetist who said, yeah, we've got a wings fall off button on our anesthetic machine. This isn't that, but this is an example of how an on-off button next to the main menu button might, in the wrong context, lead to somebody reaching for the menu button and accidentally, maybe, switching the monitor off. I don't know. I don't know whether that's true or not. There's no reason why that should be there. It could be there. It could be there. It could be anywhere, but right next to the main function button. Medications we know are a big issue. We've done some work in trying to make medication labels more visible. There is one group of safety that thinks that, well, we should just make the labels really difficult to read, so it forces the anaesthetist to read the label, which is nonsense if you know anything about human cognition. But convincing anesthesiologists or convincing people that that's the case isn't always easy. But here we were experimenting with what if we display graphical information, it adds a distinguishing feature that might make it easier. Less easy to make those mistakes. Came out of a mix-up in fact a drug that was hung and what the lines were labelled, which could have been which wasn't noticed because it looked like this, which was not obvious. So it wasn't obvious from anywhere other than about 3 inches away from the bag that this mistake had been made. Visibility, opacity in healthcare systems is a really big issue. Teamwork training, I'm going to skip this because I kind of move on. Teamwork training can be valuable. and we know that there's some good evidence around it. It's not always the most successful. In fact, when I talked about Maisha and that team there, this was the team we were working with when we were trying 18 months before to deliver teamwork training and checklists, and this is sort of pre-surgical safety checklists. Emphasis placed on maintaining the mood of one surgeon over putting training into practice. So when you try and implement some of these things, having one person who disrupts the whole thing can be really problematic, as was the case there. But when you start combining teamwork approaches with other systems design issues, you can start to get more success in both in surgery, which is published in Annals of Surgery, and in trauma care. The other work that I've really enjoyed doing is looking at sterile processing and how we clean and reassemble instruments and sterilize them and get them back into the operating theaters for surgery. It's fascinating to me that actually nobody ever looked at this before. And it came from a conversation I had with a surgeon who says, you know, those people on minimum wage down in the bottom of the hospital, they don't care like I do. And I said, you know what, I know a few things about people in systems, and I think that people down, even though they're on minimum wage, are probably down, probably really do care. And indeed, the people down on minimum wage, not treated very well, down in the bottom of the hospital, have selected to be there even though they can earn more money flipping burgers, because it has meaning to them. And they end up being amazing experts in all the stuff that you need to do just to get all the right things in a tray. And it's fascinating to me that of the thousands of studies there are on surgical safety, there are almost none on sterile processing. Robotic surgery is something that also of interest to me because it has really profound changes, not just for the surgeon, what that does, but everyone else in the operating room, and indeed how you even plan and roster staff and manage the careers of theatre staff. So introducing a surgical robot has really, really profound effects on lots and lots of different things. It's not just how we train as a surgeon, and yet we've introduced these into our theatres without necessarily considering all the implications and what we can do to, the things that are available to us to address some of those issues. So this is a study we did using serious games to improve things like docking, which is where you have to move this big robot into place, and a big robot with lots of overhead lights and things means that we observed multiple times in which the robot would be bashed against. In fact, if you go and look at a surgical robot, the chances are you might see little scuff marks on the top of it, which demonstrate this is what's happening. And there are things that you can do to actually provide fun games to train some of these situations. Thank you. The last piece that I didn't get to talk about, but that's all right, you can go and look at that, was some work we did looking at transferring these very sick congenital heart babies from surgery to ICU using pit stop methods, but I don't get to talk about that because I need to finish. Thank you so much. I hope that's been entertaining. These are some works that I would recommend, and I'm really happy to talk to you more. Thank you for your attention.
Thank you so much, Ken. That was definitely entertaining, but also very informative, and I think probably provoked a lot of thinking